So this is a famous problem known as the Monty Hall problem. Now Monty Hall was an American game show host who hosted a game show called Let's Make a Deal in the 1970s. You can actually find some videos on YouTube of Let's Make a Deal, and it really is repellent. It must have been on when I was living in the States, but I didn't ever watch it, and it really is awful. And, I hadn't actually watched it till last week. But it was mainly a thing people had to make guesses about things, and they got ridiculous prizes. And in this particular thing, there were the way it was, what actually happened was that the event took place in 1975. Then there was a woman called Marilyn Vos Savant, who has, in the Guinness Book of Records, as having the highest IQ score ever, an IQ of 228. I don't really understand about IQ, but that's apparently the world record. And she was employed by Parade magazine to as a sort of problem-solving person, and she had a column called Ask Marilyn. And in 1990, somebody wrote in about the Monty Hall problem, this particular game show thing, and it's a probability thing. So the situation in the game show, at least as presented to Marilyn Von Savant, was there are 3 doors. And behind these doors, one door has a car behind it. I'll tell you what the car is actually. It's not that I know anything about cars. I've lost it now. I made a careful note of this because I thought it would interest the car people. It's a Lincoln of some sort. Anyway, I can't find it now. There's a car behind one of them, and behind the other 2 are goats. I mean, one of the repellent things is that they seem to have live animals as these booby prizes. One of the ones I watched, there was a camel as the booby prize, and they had actually somebody winning a camel. What they had to do with it, anyway, they didn't actually win it on the one I saw. They actually got the proper prize, which was a whole fitted kitchen or something. So there are these 3 doors, and so there's a probability of 1 in 3 that the car will be behind each of these doors, and the person chooses one of the doors and says, I think it's behind that door. So we'll do this. My doors are upside down mugs, and there's a car underneath one of these mugs, which I'm not going to give to anyone because it's from a jigsaw, which I give for one of my grandchildren. So I'd like perhaps Taylor, you'd like to choose one of these to try and guess where the car is.
Is it a red car?
It is a red car, actually.
All right. How about the one stage right?
This one?
Yes.
Right. So what I now say, right, you've chosen that. Now, what I'm going to help you now, and I'm going to show you that the car is not underneath this mug. And now the thing is, now I say you can choose again. You can either stick with the one you've got, or you can move to the other one.
I'll stick.
Right. Now, why do you stick?
Well, you turning the mug over didn't change the probability, did it?
That's interesting, isn't it? So you think there's a probability of 1 in 2 that it's underneath each of these?
I suppose.
Yeah, I mean that's actually what Monty Hall told his customer at the game show, and that's actually what in fact that's not true. There's a higher probability that it's under here, because I actually know where it is, but that doesn't really that's nothing to do with it.
That's not fair.
Well, no, but I had to know where it was in order to tip this one up to show you. And of course, the point is, when I tipped this up to show you this was empty, I was using the information I had of knowing where the car is. So there's some new information come into the game. So what happened is Marilyn Von Savant wrote an article, the answer to this problem, saying there's still a problem of 1 in 3 that it's under there, and there's now a problem of 2 in 3 that it's under here. That's what she wrote. And the result of this was there was a whole host of correspondence. The magazine had 10,000 letters from people saying what an idiot she was, how she was clearly wrong, because there was clearly a chance of 1 in 2 that it was under each of these. So, and there were lots of them for academics. There's Robert Sachs, PhD, says, you blew it. As a professional mathematician, I'm very concerned at the general public's lack of mathematical skills. Please help by confessing your error and in future be more careful. And there were several along these lines. There's one down here. I'm sure you will receive many letters on this topic from high school and college students. Perhaps you could keep a note of these addresses to help you with any future problems. And the final one, which comes from somebody, these are all maths PhDs writing in, somebody who worked for the US Army Research Institute. You made a mistake. If all these PhDs were wrong, the country would be in a very serious trouble. Anyway, all the PhDs were wrong, so let me try and convince you of that. Not by showing where the car is, because obviously that's, in a sense... But the point is, before this was done, I mean, when Taylor made her choice, there was a probability of 1 in 3 that it was under here. So there was a probability of 1 in 3 that you were right, and there's a probability of 2 in 3 that you were wrong. Now me taking note, it didn't affect that. There's still a probability of 1 in 3 that you're right, and a probability of 2 in 3 that you're wrong. So there's actually a probability of 2 in 3 that it's under here. And there's a probability of 1 in 3 that it's in there. So that is actually the situation. It doesn't really matter where the car is. That's what the probabilities are. And that's actually, so I'm just trying to say it again. When we started, there was a probability of 1 in 3 that it was under here. There was a probability of 1 in 3 that it was that side of the line, and 2 in 3 that it was that side of the line. But then when I tell you it's here, not under here, then that 2 in 3 all sort of goes onto that mug. So there's probability of 2 in 3. And in fact, people have done experiments, you know, doing lots of trials of this to check that this does actually work, because people still don't believe it. Yeah. It is actually the case. And so, but it was, anyway, I wonder what Donald Trump thinks about it. Since all these PhDs, including this army guy, thought this woman was an idiot, but she was actually correct. Anyway, that's the Monty Hall problem. So,